Let's talk about production-tuned Docker containers. So when I think of production-tuned containers, I think that a good production-tuned container is the same exact build that you're going to be using in development. At runtime, there might be a few differences. In the case of PHP, you might be using Xdebug in development, and you definitely don't want that module enabled in production. You might also want to use OpCache in production, but not necessarily in development. When I think of production-tuned containers, I also think of the size. So let's create a list and go over these things real quick. So we're going to talk about image size. I'm just going to label this as production tuned containers. I would say images and containers. There's some things you can do to the image, and there's also some things you can do to running containers to tune them for production. So the first thing that comes to mind for me is image size. The smaller the image size, the faster it's going to pull into your production servers and build. Another area for tuning our Docker images for production is removing development specific items that production doesn't need. So I'm just going to call that removing development specific stuff. And on the flip side, there's production specific stuff that we want to enable when we're not in development. There's definitely more production tuning topics, but these are the specific ones that we're going to look at today in the context of PHP. So to start off, we're going to create a new Laravel project to demonstrate some of these items because there's some good examples from the Laravel codebase of things we want to tune in production and in development. So I'm going to start out with a new Laravel project. I'm going to use Laravel new. And we're going to change into this directory. I'm going to create a Docker folder. So make dir Docker. So inside of this Docker folder, we're going to maintain our Docker setup. I'm also going to add a new Docker file here so that we can demonstrate a few things. Next, I want to look at Docker images. So if I run Docker pull, we're going to pull the official PHP image 7.2 Apache stretch. I usually recommend this image when you're first starting with PHP and Docker just because it includes Apache and you don't have to worry about setting up Nginx and worrying about networking between PHP, FPM, and Nginx. We go over that in my Docker for PHP Developers course, but for this video, we're going to use Apache stretch, and Apache works great for horizontal scaling in production as well, and it's a good choice. So I'm going to pull this image so I can compare the image size to a couple other variants. So it looks like I already have this image, but if you run this on your own machine, it might take a while to download the image. Next, I'm going to run Docker pull PHP. We're going to use 7.2 and the Alpine. So if I run Docker images, so if I look at these two images and compare them, the Alpine variant is 80 megabytes roughly, and the Apache stretch image is 377 megabytes. So the base image size is much larger from the Debian stretch image, but at the same time, it provides us with Apache and a Debian base, which I think is a little more convenient. I'm not as familiar with Alpine, but you can see here if you were using the Alpine image that you would save a lot of size. So in our Docker file, we're going to extend from the official PHP, and we're going to use this 7.2 Apache stretch image. We're going to copy in our Docker project, and inside of this image, it's var HTML. So let's build this image and then check the file size after copying our project in. If we run docker build, we're going to call this image PHP perf. The Docker file we're going to use is in the Docker folder, so Docker file. And the context is the current path, which is the root of the Laravel project. Now if we run docker images, our new image that we've built here is now 407 megs. So you can see that we've added 40 megs of copying in our project. Next, let's run a bash session with our new image that we've built. So if we do docker run, we're going to remove this container when it closes. We're going to use interactive mode, and this image is called PHP perf, and we're going to run bash. So if we look at this directory, it's our typical Laravel project. And notice how we don't have the node modules folder in here because we actually haven't installed any node module dependencies. So if we exit this container really quick and we run yarn install, if we rebuild this image, we're going to tag this as PHP perf and use our Docker file. Now if we run our bash session again, so docker run, remove the container, we're going to use our PHP perf image and we're going to run bash. If we run lsla now, we have our node modules folder. So if I run docker images, So you can see that we've jumped up to 516 megs now that we are copying in our node modules. The interesting thing though is that we don't actually need the node modules folder in our final image. We need that folder in order to build our dependencies for our application, but it does us no good at runtime. So therefore, we don't really want the node modules folder within the final Docker image. So if we create a Docker ignore file in the root of our project, because that's the context we're running our Docker builds from. So we add a .docker ignore file. This works similar to the git ignore file. So if I add node modules, if we go back to the console and run docker build, this change should ignore the node modules folder and not copy it into the image with our copy instruction within the Docker file. So now if we run docker run, we don't have the node modules folder anymore. And if we exit the container and run docker images, the size of our container is back to 407. Another important folder to ignore here is the Git folder. You're probably version controlling your projects, and you don't want to copy in the Git folder into your Docker image. And there's going to be other files here that might contain sensitive information that you don't want copied in here. For example, you might have a .env file. You definitely don't want to copy that in if you're using a Laravel project. So we're going to add a .env here as well. I will note that if you are using a volume in development, you will have a .env file for your development environment, but that will be coming from your local machine volume. And when you run a Docker build to build the image, it will not include a .env file in the end. So now if we run docker run, let's grep for .env. So we do have an env file here. If we rebuild this image, we run docker run. Now we only have the example file being copied in. You might be asking, how do we get our final front-end build into our Docker image that we need to run our application? And there's a couple ways that you could do this. You could build the front end and build your composer dependencies and then copy the final artifacts into the Docker image with your Docker build. So what I'm suggesting is that part of your build process could live outside of Docker. Some people might frown upon that, but it actually works pretty well, and I do it on my own projects. So if I exit and I run yarn production, I'm running this local, by the way. And if I also run composer install, so note I'm doing this before I'm running docker build, and now if I run docker build, it's going to copy in my final app.js and app.css files into my Docker image. So if I run docker run, and I go into the public folder, you can see that if I go into the JS, I have my production app.js file. I want to note when you're in development, you're using a shared volume, and your local app.js file is going to override this file that's living in your final image. And this is the production ready version of the app.js, whereas your local development environment using a volume is going to be the latest app.js build that you're doing at the time. So for instance, in development, I might have a console running yarn watch. So using yarn watch locally, every time the files change, my Docker volume is going to make sure that my Docker image has the latest versions, which is nice for development. I don't necessarily have to have my entire development tool chain inside of Docker. And in fact, I think it's a little easier just to run some of this stuff locally, and it hasn't really caused me any issues, and I have not run into any traps. So I'm going to exit out of this. So the other thing I might note as well, inside of our resources folder, we have an assets folder, and inside of here, a JS folder. We don't really need these files during production, so you could even ignore these unless you're going to build your application within the context of Docker. We're not going to talk about Docker multi-stage builds in this video. That's another way that you can build your front-end dependencies and install your composer dependencies in the context of Docker, but not have like the folder, the node modules folder, inside of your final image. So that's the goal really, is make sure that these files and folders that don't actually need to be present in production aren't in your final Docker image. Next, let's move on to more of like runtime performance stuff. So in the context of my Docker file, we're not going to get into the nuances of the CMD instruction versus the entry point. We're just going to add a CMD instruction. I'm going to show you how at runtime you can tweak your container for production. So I'm going to add a CMD. We're going to put this file in user. local bin. I'm going to call it start. And inside of my Docker folder, so if I go back over to the root of my project has a Docker folder, I'm going to add a start.sh so I get my syntax highlighting. We're going to run set e. And so if anything within this script runs and exits with a non-zero status code, it will cause the container to shut down as well. So we're going to set an env variable here, and it's going to use the app env, and the default is going to be production. We're going to add some logic here. So if env does not equal local, by default, Laravel's app env is local. So if I go over to my example file, the app env is local. So we're going to use that for our development environment. Then, inside of this condition, we're going to echo some output to the Docker console, caching configuration. So inside of the context of Laravel, we could do cd var www html and php artisan config cache. And we can run php artisan route cache and PHP artisan view cache. So let's actually break this up onto multiple lines, which makes it a little easier to read. So using these parentheses, we're not going to actually change the directory for the rest of the script, just within this context of these parentheses. And this is a nice way to just run some commands and not lose the current working directory. I'd also like to point out that this Apache Stretch image that we're basing our image off of has a CMD instruction already built in. So if I go over to GitHub, if we go down to the bottom of this image, we can see that this Docker image is going to run this Apache 2 foreground script. So we need to actually execute this script within our own shell script. So back in our start sh command, we're going to run exec Apache 2 foreground. And what this is going to do is replace the current shell, and the process ID 1 is going to be Apache 2 foreground. So if we go back to our Docker file, we need to copy this file in. So we're going to copy Docker start.sh to user local bin start. And now we need to make this executable inside of the image. So we're going to run chmod +x user local bin start. We're copying in this script and we're naming it start inside of the image, and then we're making it executable. And it's going to be the default command for this Docker file if you don't provide your own command. So with this start script in place, we should be able to rebuild our image and run those commands because our environment is not being set at the moment, so it will default to production. So if I run docker build, if we run docker run, we're going to remove this container when we're done. We're going to use port 8080. And inside of the container, it's going to map to port 80. We're going to use the PHP perf image. So it looks like we have an error within our start script on line 7. So we need a space here. So if we run docker build again. So if we run this container now in the foreground, we can see that it looks like we have an error. If I run docker ps, we don't have any containers running because we had an exit. If we run docker run again, let's get that error again. So it looks like we're unable to prepare the route API user because it's using a closure. So we actually, out of the box, if we go to the routes folder and API, we have this closure. So let's just comment it out for now. Let's check the web. It's also using a closure. So let's just change this to view. And this view method just allows us to render the template here, welcome. So now if we run docker build again, if we run docker run again this time, let's see what happens. So it looks like our caching configuration, it looks like we have an extra space here, but whatever. So it looks like our configuration cache worked, our route cache, and our blade template cache worked. So because this is production, we're running this condition and optimizing our image for production at runtime, which is really cool. So let's exit this and run our container like we would with development. So if I go back to docker run, we're going to set an environment here. We're going to call it app env equals local. So now you'll notice that we have no output from our condition. We could even further debug this by this is helpful if you want to debug your start scripts, just echo the env is env. Let's just fix this space. So once again, we need to run docker build in order to update this. If we run docker run, we're going to set app env to local again. You can see that the env is set to local. So this is how I would run the container in development. I'm not relying on config cache or any of these other commands. And inside of here as well, we could also disable things like Xdebug. So let's go over that. Before we do that though, I'm going to run docker run again, and I'm going to remove this environment variable and show you the output. It says it's production just to prove to you that it is the default. So the env is production and all these things are running. So the next thing that we can do inside of our Docker file is peckle install Xdebug. And we need to use the Docker PHP ext enable Xdebug. So we're installing Xdebug via peckle, which the official PHP image provides. And the image also provides a Docker PHP ext enable script that allows us to enable extensions. So first, let's get this thing running and verify that Xdebug is enabled. So docker build. And once you set up your Docker file, you don't really run build a lot once it's ready to go and you're just developing. This is when you're trying to build a brand new image and just work out all the kinks. So next, we're going to run docker run. And this time, we're going to run bash again. If I run phpm, I'm going to grep for Xdebug. Looks like we have the Xdebug module enabled. So next we're going to run php -ini. Let's go look at this Xdebug configuration file. So I'm going to output this file and it just enables the extension. That's all it's doing. So what we can do inside of our container runtime, this start script, is inside of this when env does not equal local. So we can run removing Xdebug. We're going to run rm, and we want to force this to happen even if it's not there. And we're going to paste in this path to this ini file. So with that in place, we can run docker build. Next, we're going to run docker run. So we're going to run this in the foreground, and we're going to just set this to production. We're going to run this container in the background. So I'm going to add the D flag. So if I run docker ps and make sure that this container is running, I can run docker logs. I'm going to follow them, and we just need the first couple characters of the container ID to make it unique. So we can see our output here that we're removing Xdebug, and we're going to jump into the container and verify that that's true. So I can run docker ps to get the container ID again, and I can run docker exec. I'm going to use interactive mode. I'm going to reference CA and bash. So this will allow me to be inside of the container with a bash session, and I'll be able to peek around. So if I run php-ini, we can see that the additional ini files parsed. It is not including the Xdebug ini file anymore. So in production, we do not have Xdebug enabled, which is exactly what we want. It does have a performance overhead, even if it's disabled. So we don't even want it to be recognized by PHP. On the flip side of removing things like Xdebug in production, we want to enable or change certain ini settings in the way that they behave in production. The OpCache module is an excellent example that we're going to use to demonstrate this. So the first thing that we need to do is actually install the OpCache module in our Docker file. So in this run block, I'm going to add another line here. And this official PHP image comes with a Docker PHP ext install command. And I'm going to install OpCache. And on a Laravel project, you would typically also have PDO, MySQL, etc. This will install the OpCache module with the default settings. Inside of the Docker folder, we're going to add an opcache.ini file. So opcache.ini. The OpCache settings that we're going to use here come from a book called Scaling PHP Apps by Steve Corona. And this has some really good information. I'll link this in the video notes of different settings and what they mean within OpCache. So I'm going to paste in some specific configuration that I have prepared ahead of time. So inside of our ini file, we're going to enable OpCache. And I've noted a few things based on that article that will help you understand these settings at a quick glance. And note here that I'm using environment variables to set these. Since we're using Apache, we're able to set these environments and use them within our INI files. If you're using PHP FPM, you need to make sure that you're not clearing your environment from your configuration. And the official PHP FPM image makes sure that it does not clear environment and it works out of the box. So I just make that note. If you're using FPM and this isn't working, that's why. It's because clear env is set to off. So there's a couple settings here that we're going to use environment to configure, and that is validate timestamps. This is the most important setting between development and production. 0 is recommended in production, and in development, we want this to be set to 1. Setting this to 1 is critical in development, so any change we make to files reflects immediately. We're allowing this to be customized, OpCache max accelerated files, because each project's different. So if I run this from the command line, in our specific project, we have about 5,800. I'm going to set this to like 8,000. And what's nice about setting it with environment is that we can provide some defaults and then tweak this per environment. Inside of the Docker file, there's an env instruction. So at the top of my Docker file, I'm going to have an env instruction. I'm going to set this to 0, just like production would want. We're going to set the max accelerated files to 8,000. This is a Laravel specific image, but you might have a more generic PHP image, and this will allow you to tweak it depending on the project and how many files. And we're going to set the OpCache memory consumption. I'm going to set the default to like 128, or it could be like 256. It's up to your project, but these are some defaults. And if we don't set any env when we're running containers, these env values will be used. So with these settings in place, we also need to copy in the INI file. So we're going to add copy docker opcache.ini, and let's go back into the image and run docker run, and we're going to use bash and php-ini, and this is the path that we need to copy this file into. It's going to scan for additional INI files within this path. Inside of our image, we're going to copy it to this path, and it's going to be called opcache.ini. So if I exit this container and run docker build, okay, now that our image is done being built, let's run docker run. We're going to go back in with bash. Inside of the image, we're going to run phpm. And notice that we have the Zend OpCache module. So next thing I'm going to do is I'm going to use env to override this and show you. So this is what we might have in development. Then we're going to run docker run. We're going to set the validate timestamps environment variable, and we're going to set this to 1. This is what we would run in development. So if I run docker ps, docker exec, interactive 96 bash. So we're going to run php I, and we're going to grep for opcache.validate. So we can see that validate timestamps is on. Now in production by default, if I run docker run, we're not going to set this. We're going to rely on the defaults that we set in the Docker file. Now if I run docker ps and docker exec, interactive 8f bash. If I run php I and grep for opcache.validate, now you can see that timestamps are off. So this allows us to enable and disable settings and change settings at runtime with environment. This is really useful to tune your containers in production for using OpCache, because in production, we don't need to validate timestamps. I hope these techniques are useful to you in tuning your Docker images for production and also making them flexible enough to use in development. If I can emphasize one thing, it's so critical in my opinion to make sure that your Docker images work in any environment, because you don't want separate builds for production than what you're running in development. Using the techniques that I've showed you, you can make your images flexible enough so that they'll work for you in development, but they'll also be tuned for production when you're ready to take them to production.